very much, Guru, for your introduction and your comments. And also I want to thank John and Al for introducing the forum and also the importance of it relative to the NAE mission. I particularly like the comments from John and Al about the an analogy with flight systems, where there are subsystems and systems, and I think that's very appropriate for what we're talking about in our food and agricultural systems. I also want to thank Darrell West of the National Academy of Engineering. He's provided outstanding help as we've been organizing this event, and he's helping today. And so thank you especially to all of you at the National Academy of Engineering for organizing and helping make this event today possible. And thank you for to the professional societies that have been mentioned already by John, and to our outstanding speakers, as well as the organizing committee, who along with me were Brahm Verma, Paul Singh, Katie Migliaccio, and Bruno Basso. So thank you very much. Now, in introducing the program, I wanted to emphasize that our current food and agricultural systems are highly impressive. They're technologically advanced, and they provide safe and affordable products to meet our needs. And we take them for granted. We can go to the grocery store and the shelves are typically full until the pandemic hit, as has been alluded to already. But so this has been an amazing accomplishment that most people are unaware of all the logistics and ways that our food appears to us. So what's the problem? Well, to reach these current supply levels, we've expanded land area, we've increased irrigation water use, we've increased use of energy and other resources, in addition to having a lot of new technologies that have been just very impressive. But these approaches have led to unwanted externalities. For example, we're a net emitter of greenhouse gases to the atmosphere. Our processes may damage and contaminate water and soils. We have a lot of food waste that are just wasted resources, and it's also led to biodiversity losses. Recent National Academy studies have concluded that these approaches are really not adequate to meet future needs because of the growth and limited amounts of water and land that are available for continuing to expand the use of those resources. So business as usual just will not succeed. And this has been alluded to by John and Al as well. So we have to transform these current systems to meet future demands while also reducing the resource uses, reducing and eliminating losses, recycling and reusing the resources that are available, and continually regenerating soil, water, and natural systems. Some producers and industries are beginning to address these challenges, and we really appreciate their leadership in doing so. But we have to accelerate these efforts to achieve the kind of sustainable and resilient food and agricultural systems that are needed. So some of the Academy reports have suggested that ways to do this, systems approaches are needed, and I'm pleased to see the emphasis on systems approaches by both John and Al and also Guru. And so there are different systems and subsystems and systems of systems that you need to think about. And so some of us define systems to be supply chains that include pre-production, production, transportation, processing, packaging, and also even waste management activities. And in studying these current supply systems, we found that they're mostly linear, with the losses occurring at different activities that are taking place across the supply chain. And much of these losses are discarded as waste. And so this is where we lose the resources, and we also contaminate the environment, and this leads to biodiversity losses. So our current systems are leaky, and they're also vulnerable to shocks. So we need innovations across the supply chains to address these resource losses and the broader impacts, not just on innovations that increase productivity. They all need to be addressed. One of the concepts that we'll discuss today is that of circular economy systems. A recent study by the American Society of Agricultural and Biological Engineers suggests that transforming toward of our current systems into circular economy systems would lead to more productive, sustainable, and resource efficient systems with less waste. So a key question then, it's a complex question, but it's, can the use of the circular economy concepts help guide transformations to provide higher supplies, achieve net zero or negative carbon emissions, sustain natural resources, eliminate environmental contamination and biodiversity losses, and be resilient to external shocks? These are individual goals that many of our scientists and engineers are working on in isolation, but we have to have the systems approach in order to identify the problems and address all of them at the same time. And I've concluded, though, that defining systems to be supply chains is really needed, but this perspective of systems is not sufficient. Food and agricultural systems are affected by and also affect social, policy, economic, environment, and health issues at different scales. And this implies a need for systems approaches to be defining systems at different scales and how they interact. But many questions remain. What technologies are needed? What policies might be needed? What scales are important? And how do these interact with each other? And how can human health be more directly considered, both in terms of the impacts of our food systems as well as the impact of health on food systems? This program today can't really address all of these types of questions, but we do want it to set the stage for more efforts in the future from the National Academy of Engineering Sciences, National Academy of Engineering, but also National Academy of Science, Engineering, and Medicine, and beyond that. So the goals of the forum today with the speakers that we have are to inspire engineering disciplines to help lead the transformations into circular, sustainable, and resilient systems. The second one is to discuss systems approaches and frameworks to guide these transformations. And three, to begin identifying the needed investments from public and private sectors. So the program itself is organized into 3 blocks. In block 1, we'll focus mostly on characteristics and accomplishments of our current systems, but also some of the future innovations that are imagined and envisioned in different areas. In block 2, we'll discuss concepts for transitioning into more sustainable and resilient systems. And in block 3, focus on the engineering for sustainability and for resiliency. We also end today with a keynote address on complex systems challenges. Now, as we go through this, I'll introduce the moderators for each block when it's their turn when it's each block's turn. And so I'll start today with introducing Chuck Rice, who is the moderator for block 1. Chuck is a university distinguished professor in soil microbiology at Kansas State University. And he's a chair of the Board on Agricultural and Natural Resources of the National Academies of Science, Engineering, and Medicine. So Chuck, thank you.